3.1, we just kind of dove into what is a polynomial and all the details there. Today, we're reviewing. Add, subtract, multiply. All stuff you already know, we just got to review how to do it. Okay, so we're going to start with adding and subtracting polynomials. You guys know the basics. To add and subtract polynomials, we're going to be looking to combine like terms. Okay? Now, keep in mind, in order for terms to be like, all the variable pieces have to be the same. So the variables and their corresponding exponents must be identical. I've written these out similar to what you would often see adding and subtracting in terms of there's a parentheses with a plus or minus sign in the middle. So my recommendation there is just watch for the sign. Know, are you adding or subtracting this time? Okay? So as we look at example A, what are we doing on example A? You'll want to note that this is an addition problem, yes. What do you see? What can we put together?
We can put 6x cubed and 2x cubed together.
Okay, 6x cubed and 2x cubed can go together. They're both x cubes. And what is 6x cubed plus 2x cubed? 8x cubed. Okay, remember, keep your variable pieces the same and add your coefficients out front. What would be smart to put next? The x squares, right? You may or may not be required to put it in standard form. However, if you are, this is just getting yourself ready. X squared would come next in standard form. We've got a 1x squared plus a negative 8x squared. What is 1x squared plus negative 8x squared? 1 plus negative 8 is?
Negative 7x squared.
Negative 7x squared. Guys, these are easy questions today. Just saying. Things go quicker if you guys answer questions. What should go next?
4x.
Okay, 4x. What's 4x go with? Okay, 4x doesn't have any other like terms, so just carry the 4x down. And that leaves what? Ah, there we go. The negative 7 and the 3, which are constants. And negative 7 plus 3 is? Okay, so 8x cubed minus 7x squared plus 4x minus 4. If Savas doesn't say anything about standard form, they might not care about standard form. But I believe it does mention standard form, so just beware. When I mean remember standard form, highest exponent down to lowest exponent. Okay, and we're done. Okay, moving on. B. What do you notice about B? Okay, pay attention right off the bat. This is a subtraction problem, right? Notice that sign there. Now, when I teach this, I tend to just start looking for like terms, and I tend to just remember that we are subtracting each one. Now, I did have someone in my morning class ask about changing the signs. Could we do that as well? You could. One option, and this is not what I'm going to do necessarily, but I'll demonstrate. One option is, what does subtracting mean? You can make this a plus sign, and then what? It becomes minus, minus, and plus there. Is that an option you could do if you wanted to? Yes. Okay. If that is not what you want to do, then just remember we're subtracting each time. Okay, so 3x squared y squared goes with what?
2x squared y squared.
2x squared y squared. And what is 3x squared y squared minus 2x squared y squared?
X squared y squared.
Yeah, it's 1x squared y squared, but you're better off to just put x squared y squared. And I will say from past experience, Savas doesn't like ones in front, do they? So I don't know if you've tried that, but I feel like, I don't know that I've found a time that they like the ones. In terms of standard form here, when you've got x's and y's mixed together, there's not really a good way to think standard form. So I'm just going to go in the order they give. excuse me. What about 2xy squared? What does that go with? 3xy squared. And what are we doing here? Subtracting. So 2 minus 3 is? Minus xy squared. So minus 1. And I'm just keeping my terms the same. And 6x squared goes with negative 2x squared. Now, and this is where you have to remember what you're doing. What my brain's thinking is I'm doing 6 minus negative 2. And what is 6 minus negative 2?
8.
Becomes 6 plus positive 2, so plus 8x squared. Okay? Questions with what we're doing? Okay, remember your variable pieces just stay identical when you're adding and subtracting. Okay, what are we doing on C? Okay, C, we are adding. So again, look for those like terms. What do you want to start with?
4a. 4a. Just 4a.
4a to the fourth. And what does 4a to the fourth go with? Nothing. So I would just carry that down. I would put it out front because it's the highest exponent. Continuing on. Negative 6a cubed goes with 5a cubed. Negative 6 plus 5 is? Okay. Minus or negative a cubed. Keep going. Minus 3a squared goes with?
7a squared.
And minus 3 plus 7 is? 4a squared. Okay. What else? A goes with 2a. A plus 2a is 3a. And lastly, 1 goes with negative 2. And 1 plus negative 2 is negative 1. So 4a to the fourth minus a cubed plus 4a squared plus 3a minus 1. Got the basics? Okay, one more in this section. What are we doing? We are subtracting. Okay, so 2a squared b squared goes with
3a squared b squared.
3a squared b squared. What do we get when we put 2a squared b squared and 3a squared b squared together?
A squared b squared.
Okay, 2 minus 3 is going to be negative a squared b squared. Someone doesn't like the negatives back there. Okay. Next. What about 3ab squared? What does 3ab squared go with? 7ab squared. Did they switch it up on us? They did. So beware. So in this case, we're doing 3 minus 7, which is going to make it minus 4ab squared. And lastly, we have the minus 5a squared b, and that's going to go with minus 9a squared b. What are we doing? My brain says negative 5 minus negative 9, which is what?
4a squared b.
Yeah. Becomes negative 5 plus positive 9. So we have a plus 4 a squared b. I'm going to go with the hardest part of this portion of the homework is going to be getting your variables correct. Okay? That's going to be the tough part. Okay, questions on adding and subtracting? Okay. Let's multiply. Okay. To multiply. You guys know how to multiply, right? We've done probably more multiplying than adding and subtracting this year. Basic concept. Officially, it says use the distributive property. Basically, we're thinking FOIL, yes. It's just bigger concept, bigger versions of FOIL. Remember, after you multiply, you do want to clean up, put your like terms together, just like what we were doing above. What I'll remind you as we look at A. A is a little bit bigger than FOIL, isn't it? The concept when we're multiplying. Every term in the first parenthesis has to multiply by every term in the second parenthesis. Okay, so be orderly in however you do that. There's not just one right way to do it. I tend to start with like my 2m here and distribute it, multiply it by everything in the second parenthesis. So let's see how rusty we are with multiplying. 2m times 3m squared is what? 6m cubed. So 2 times 3 out front is your 6. And then remember when you're multiplying and the variables are the same, you're adding the exponents. Continue. 2m times minus 4m is?
-8m squared.
Minus 8m squared. 2m times 2? Plus 4m. And now take your 5 and distribute it if you haven't already. 5 times 3m squared. 15m squared. 5 times minus 4m. It's minus 20m. And 5 times 2 is 10. Okay? Don't stop here. Okay? You need to give the cleaned up version, whether you're, putting something on paper for me or whether you're talking for Savas. What can we put together? Six m cubed can stay 6m cubed. Minus 8m squared goes with 15m squared. Minus 8 plus 15 is 7m squared. And then 4m goes with minus 20m. And 4m minus 20m is minus 16m. And don't forget the plus 10. So 6m cubed plus 7m squared minus 16m plus 10. Okay. Questions here? Okay. B is similar, yes? Let's see what we can do with B. Check your exponents. 6n squared times n squared is what?
6n to the 4th.
Okay, 6n to the 4th. 6n squared times n is 6n to the 3rd. 6n squared times 3 is 18n squared. Repeat with the -7. -7 times n squared minus 7n squared. Minus 7 times n minus 7n. And minus 7 times 3 minus 21. Okay. Any cleanup we can do? One small set? 18n squared minus 7n squared can clean up. The rest stays the same this time, doesn't it? So 6n to the 4th plus 6n cubed. What is 18n squared minus 7n squared? Okay, plus 11n squared minus 7n minus 21. Okay. What's the trick on C?
It's two of the same sets of parentheses.
Okay. In terms of squaring it, we are going to square it, but keep in mind that means that you need to think about it as 7m squared minus 3 times 7m squared minus 3. And here's what I'm going to warn you of. If you're squaring it, it tells you your answer is going to be 49m to the 4th plus 9. I'm going to tell you you're wrong. That's not the right final answer. Okay? So, just an FYI, that's going away. Okay? When you have that square on parentheses, remember it's parenthesis times parenthesis. So basically we're setting ourselves up and we need to FOIL. Yes? Okay, so 7m squared times 7m squared is what? 49m to the 4th. Outsides, 7m squared times minus 3 is minus 21m squared. Now distribute the negative 3. Negative 3 times 7m squared. Another minus 21m squared. Minus 3 times minus 3. Plus 9. What happens with those middle terms?
They cancel out.
Do they?
Actually, really not.
Okay. Fair answer.
Well, they're both negatives.
Okay, so they're not opposite signs, right? We want them to cancel, but they don't. So put them together. So 49m to the 4th carries on. Negative 21m squared and negative 21m squared is going to be minus 42m squared and then plus 9. So beware. The common mistake there is to just square the pieces and do it that way. Okay. What about D? Have you started D without me? Thoughts on what we need to do with D?
Can you just FOIL the first two and then FOIL again?
That's your best bet. When you have 3 pieces being multiplied together, your best bet, pick 2. It doesn't matter which 2 technically. Pick 2 to multiply together. Don't forget to carry the third one down. And then we'll multiply it in once we get the first 2 multiplied. Okay, it's a little more work, but it's your best bet. As opposed to trying to multiply all 3 of them together as you go. Okay, so now, okay, what are we thinking here? What's mn times mn?
Mn squared.
Depends on how you would write that, whether I would take that or not. Yeah. I prefer m squared n squared. Now, for reference, if mn squared looked like this with parentheses, is that correct? That is technically equivalent. Would Savas go for that? I can't guarantee if Savas would go for that. Okay, but when we're vocally saying it, it's hard for me to know which way, you know. So, just kind of an FYI. Okay, continue. Mn times negative 2. Negative 2 mn. Now distribute my 1. 1 times mn. You can say plus 1 mn or just plus mn. Notice I did put the +1 here, but this isn't a final answer, is it? It's part of my work. It doesn't matter if I put the 1. And 1 times -2 is -2. Now, I'm going to go ahead and put this stuff in parentheses. And here's what I'm going to caution you of. Carry down that mn plus 4 because it's so easy to forget about it and lose track of it. Now, I would encourage you, is there any cleanup I can do in that first parenthesis? Should be a little bit of cleanup. And I would encourage you to clean up before we start multiplying again, just because it'll make things a little bit better. So, m squared n squared minus 2mn plus 1mn is going to be what's minus 2 plus 1? Minus 1mn. And I still have a minus 2. And it's times mn plus 4. And now we need to multiply again, yes? Okay. Multiply again. Depending on how your brain works, how you work, take everything in the first parenthesis, multiply it by everything in the second parenthesis. If you're someone that you'd prefer to, you can go backwards here. You can do this mn times each of the 3 things in the first parenthesis, and then the 4 times each of the 3 things in the first parenthesis. To be honest, that's what I tend to do, but the other option is distribute here. M squared n squared times mn becomes what? M cubed n cubed? M squared times 4 plus 4 m squared n squared. Now I'm going to distribute my minus mn. Negative mn times positive mn. Well, negative 1 times positive 1 is negative 1 m squared n squared. Negative mn times 4 minus 4 mn. And then distribute your negative 2. Negative 2 times mn minus 2 mn and minus 2 times 4 minus 8. Okay? And we have some cleanup. There's a little bit of cleanup here, isn't there? I'm going to carry down m cubed, 4 m squared n squared minus 1 m squared n squared is 3 m squared n squared and negative 4 mn minus 2 mn is minus 6 mn. And don't forget your minus 8. For a final answer of m cubed n cubed plus 3 m squared n squared minus 6 mn minus 8. Okay, guys. We got the basics. Okay. We're going to look at one quick application problem here. On the back side. A box is to be made out of a rectangular piece of cardboard that is 20 inches long and 14 inches wide. Squares X inches on a side are cut out of the corners and sides are bent upwards. Write an expression for the volume of the box. And we're actually going to do volume and area. Okay. Now, okay. Draw a picture. What do we have? Rectangular piece of cardboard. Okay, there's my rectangular piece of cardboard. I know it is 20 inches long and 14 inches wide. Squares, X inches on a side, are cut out of the corners. So out of each corner, there's a square cut out. And each of these squares are X inches on a side. So this square then is X by X by X by X. So all sides of the square are X in length. And that's true on each of these. Each of these corners has a square that is X by X. Okay? We're going to cut those squares out, fold the sides up, it makes a box. Our job is to find the volume of the box. So, before I go too far here, the volume of a box. What's basic volume formula for a box? Put it all together. And volume of a box is length times width times height. Okay? Huh? We'll get there. We don't know the length or the width yet either, really. Okay? We know the length and the width of the cardboard.
Oh, is that the cube?
Right. So, yeah, this is going to be of the box that we're going to form. Okay? So now, keep in mind, we have a length and width of this rectangular piece of cardboard. But we're going to cut those corners out, fold the sides up, and make a box. We're trying to find the volume of this box. Now, my volume is not going to be expressed as in terms of length, width, and height. It's all going to be in terms of X. So that's what we've got to go figure out here. Okay? So, think about it, guys. A rectangle is 20 inches long, this piece of cardboard. But we're going to cut out these two corner X's here, and these two corner X's, and then we're going to fold these end flaps up. We're going to do the same thing over here. It's 14 wide, but we're going to fold these side flaps up. What's the length of the actual box going to be? The cardboard is 20 inches long, but we're cutting out these X's. We're folding these flaps up here. Thoughts on the length of the box? Close. Close. You're getting there. So, he's on the right track. We're looking for that length right there. Because keep in mind, basically, we're going to fold those flaps up right there, yes? The whole thing is 20. What are we taking off? In terms of length, we're taking off an X right there and an X right there, yes? So it was 20, and we're going to take off 2 X's. So the length of my box is going to be 20 minus 2X. Does that make sense? Okay. Can you do the same thing with the width? What about the width of the box? The width of the rectangle was 14 inches, yes?
14 minus 2x.
You're going to take off those 2 corners. We're looking at that piece right there. And so my width is going to be 14 minus 2x. Now, the one thing we haven't talked about, height. How tall is this box going to be?
Whatever X is.
So the height is going to be X. We don't know what X is. This is all going to be found in terms of X. Does that make sense? Because where's the height? The height is these flaps being folded up, right? And so when these flaps are folded up, these flaps are all a length of X. So my height of my box is going to be X. Okay? So rewrite this volume formula. Volume is length. What do we say the length is going to be now? 20 minus 2x times height, or excuse me, width. What do we say the width is going to be? 14 minus 2x. And then what's the height? X. Okay. Now, in some scenarios, you get to leave your answer like that. What's our focus on today? Adding, subtracting, and multiplying. So we probably need to go ahead and multiply it together. What's your best option with multiplying this? Similar to earlier, we had 3 things to multiply, yes? So
On the first two, multiply the first two.
multiply the first 2 together, so multiply our parentheses, and then at the end we can multiply the x in. So let's FOIL. 20 times 14 is 280. 20 times minus 2x minus 40x minus 2x times 14 minus 28x minus 2x times minus 2x plus 4x squared. So we have all of that. Don't forget to carry down. There's still a times x. Okay? My recommendation, clean up a little bit more before you multiply the x in. So 280, and then what is minus 40x minus 28x? Minus 68x plus 4x squared. Then we still have the times the x. What happens when you multiply everything by x? Each of your x exponents just goes up 1, yes? So I'm going to have a volume of 280x minus 68x squared plus 4x cubed. Okay? And that is your expression for volume. No, we never said we were finding the volume. It just said an expression for volume. Okay? Now, real quick, before we finish up, the other thing I said I wanted to throw in, let's talk about area of the box. Okay? Officially, I just wrote it as area. Officially, when we talk about area of the box, we're thinking surface area. And generally, when we talk surface area, we're talking like area of the bottom of the box, plus area of the side of the box, plus area of the other side of the box, plus area of the front side of the box, plus area of the back side of the box, yes? That'd be the general idea. Now, we can go through that. It's a little bit more work than there's a shortcut. Where did all these sides of the box come from? They came from this piece of cardboard, yes? And think about what makes the box? Is this entire piece of cardboard the box? No. It's this entire piece of cardboard. Then what do we need to do? What did we take away? Did we take away these 4 corners here? Are you seeing where I'm going with this? Maybe, maybe not. Okay, so what would be the area of the entire piece of cardboard? The 280, or in other words, the 20 times 14, which I'll write as 280 in my next step. Okay, so that entire cardboard has that area. Now, that entire cardboard almost makes my box. What do we have to do to make the box? We have to take out what? The 4 corners? How do I take out those 4 corners here in my expression?
Minus 4x.
Minus 4, not just x though, x squared. because we're taking out each of these corners, which are x by x. Clean that up and you've got your answer. 20 times 14 was the previously mentioned 280 minus 4x squared. That represents what would be the area of the box. And that's a little bit shorter way to get there because they started us on a piece of cardboard. Okay? Okay, guys. Due to my mistake, you get an extra short assignment. Enjoy. Okay, I think it's 6 questions, 7 questions. It's my mistake. I grabbed the wrong assignment. I didn't realize what was going on until lunchtime, and by that time it's too late to fix first hour, so 4th and 5th hour get the advantage too. If you have 3.1 questions, let me know.
So is it 6%?